Assalamu alaikum. My name is Basit Ismail, and the topic that we are going to discuss is conditional statements from computer programming with a course code 6900. So the first thing that we have to know about conditional statements is that, even in real life we have to make decisions. We have to decide whether we have to go to a certain meeting or we have to work hard or whatever. We have to make certain decisions in our life. Similarly, even in programming, we have to make decisions regarding the values which we are getting from the variables or variables. Okay. These conditions usually end up in the result either false or true. However, the basic result or the basic objective when we are trying to use a conditional statement is to decide whether a specific value is, if we are taking the value of A, is greater than 5 or it is less than 5, or if we have a name, then we are trying to check whether that name is equal to Akbar or Ali, and we are trying to do something with that particular variable. So the decision, formally if we are to discuss it, then what does it say? It says that decision is described to the computer as a conditional statement that can be answered either true or false. So if we just take the example which we have given before, if we are trying to compare or check the value of A, whether it is greater than 5 or it is less than 5, then the answer can only be true or false. Either the value would be equal or greater than 5 or it would be less than 5. It can't be both at the same time. So we will get a true answer or a false answer. If the answer is true, one or more statements would be executed. If the answer is false, another set of statements would be executed. So here we have a flow chart and as well as the comparing as well as the code with it, attached code with it. So if we have declared, suppose we had a variable named grade and we declared it to be 70. So how will we use a conditional statement on it? We will use the keyword if. We are trying to check if, the keyword if, and then we would pass it the value of grade and check it against 60. If the value is greater than 60, then that person would be passed. Here it is giving you the code or the keyword of C. You can also replace it with the code of C++, cout. You have to use the cout. Instead of puts, you have to use cout. So we will check whether the value of grade is greater than 60 or it is less than 60. If it is greater than or equal to 60, then that person has passed. Otherwise, that person has failed. If we are trying to go over its flow chart, then here it is starting, the flow chart is starting. We are checking in the conditional statement whether the value is greater than or equal to 60. If the value is greater than or equal to 60 and the answer is true, then we will print passed. If the value is less than or less than 60, then this conditional statement would result in a false answer. And on the false answer, we would print a specific failed message on the console, and then we would go to the exit. Here we have beginning and exit or start and stop. Okay. So how many different types of conditional statements do we have in C++ language? We have selection statements which are used to select a specific value or select the branch branch of execution which we are going to use, and these are if statement, if else statements, and switches. And in the iteration statement, if we are trying to repeat a certain statement or certain expression, repetition of expression, we want to print the value of A 10 times, for example. Then we have different choices for loop, while loop, do while loop. And if we want to jump from the sequence, we want to jump the sequence of execution, then we use go to statements, break statements, return statement, or continue statements and return statements. We will go on each of these or the more important of these one by one. So related to these conditional statements, we have operators which can be used with these conditional statements. So which kind of operators are there? We will discuss them one by one. So we have the less than operator. It will check whether the value of a certain variable is less than a specified value, A, for example. If we are, for example, in Nadra here in Pakistan, we have to be 18. We have to have the age of 18 to do certain things. So if we are trying to check whether the person has the age less than 18 or he is older than or equal to 18, then specified different conditions will apply to it. So apply to him or apply to that person. So how are we going to use it in programming? We would just take the age of that specific person, age, for example, age of Ali, and then we would use 18 less than 18. If it is less than 18 and the answer is true, then we would evaluate certain statement and tell him that you cannot do a particular, you cannot buy a property or any kind of thing which is not allowed below 18. Similarly, if we are dealing with the age or any other variable which has to have a certain value greater than a specified value, then we would use the greater than operator. For example, even in our board exams or FSC exams, we have 33% marks or 50% marks. If the person does not have 50% marks, then he would not be declared as passed. So you can see that here this operator would be useful. If we want to include that specific value, then we would use less than or equal to or greater than equal to. For example, when we use greater than 50, it does not include 50 itself. However, the person who has to pass the course, even on 50 he is going to be passed. According to the rules, the person having 50% marks is also passed. So we would use, instead of using greater than 50, we would use greater than or equal to 50, because even the person achieving 50% marks is passed. Similarly, if the person of 18 is not eligible, greater than 18 is eligible, then what would we use? We would use, instead of using less than, we would use less than or equal to. It would include all of those people who are 18 themselves. Then we have different operators which are called equality or logical operators. Equal to, it is called equal or double equals. What does it mean? It means it is used to check the value. If the value of a specific variable is equal to a certain value, only the equality is checked, whether the value of a is equal to 5 or not greater, not less than or greater to, not greater than or less to, just equal. If the value of a is 16 and we are checking it against 5, then it would give us the result of false, because the value of 16 is not equal to 5. Not equal to is similarly opposite to it. For example, if we are using 16 not equal to 5, then it would give us a result of true, because 16 is not equal to 5, this is true, and the condition is also, or the operator is also saying that it is not equal to true. Logical and we will discuss this in later more detail. However, right now you need to understand that if you are trying to combine expressions, then you use both of these. One such example would be for example, if you are trying to check whether the person has a certain name and there is another condition, he has the age 18. You are using two different conditions, then you are going to use the logical AND operator. If you are trying to mutually exclude them, if the person is Ali or the person is greater than or the person is equal to 18, then we would use OR operator. And the NOT operator is only used for negating for checking whether the value is not equal to certain something. For example, not equal to 5. It is used, NOT operator is mostly used with equality operator in combination with equality operator. Okay. So rules of operators. How do we know how the operators would be evaluated in the C++ language or in a certain expression? If an expression, what does it say? It says that if an expression involving the relational operator is true, it is given a value of 1. What does it mean? It means that if we are evaluating a relational operator, A is greater than B. For example, A has the value of 6 and B has the value of 5. Then this would either have a value of true or a value of false. So for true would be 1 and false would be 0. So what does it mean? It means that whenever the relational operators are evaluated, then you get either a value of 1 or a value of 0. And then what does it say? It says that space cannot be given between can be given between operand and operator. What does it mean? It means that if you have there is a space there and then you have the value, this space is allowed in the syntax of the C++ language. However, if you are combining this with another operand, then this space, you cannot give space here or you cannot give space here. This that particular space between the two operators is not allowed. And then last thing, what does it discuss? It discusses that A equal to B and A equal to B, these two are not equivalent to each other. A equal to B is a check of equality. Check of equality means that it is checking whether the value of A is equal to value of B. However, A equal to B, it is assignment. Assignment, what is it? Assignment means if the value of B is 7 and the previous value of A is 17, what will happen is that 7 will get stored in the place of 17. So, A will now become 7 instead of being 17. So, these two operators and these two this operator and this operator is different. Equality is not equal to assignment. Then it discusses a relatively complex concept that the relational operators have lower precedence than arithmetic operators. What does it mean? It means that if an expression has both of these relational arithmetic operator as well as a relational operator, then the arithmetic operator will be executed first. This would be first in the execution cycle, and this would be the last one in the execution cycle. This the precedence means what operator has the highest precedence. The one having the highest precedence in an expression would be an arithmetic operator. First division, multiplication, addition or subtraction would be occurred or evaluated, and then you would check whether the value is greater, less than or equal to, or equal and equal to. So, we have certain examples of these expressions. Suppose we had declared 3 variables, x equal to 1, y equal to 2 and z equal to 3. So, if we evaluate this expression x is greater than or equal to y, what would happen? It would give us a result of 0 or false. Why? Because x is 1 and y is equal to 2. What is it checking? It is checking whether 1 is greater than or equal to 2. So, it is checking, it is doing both things. It is also checking that 1 is greater than 2 or 1 is equal to 2. So, it is neither equal to 2 nor it is greater than 2. So, the answer would be false. X plus y would just add the both variables together. So, x has the value of 1, y has the value of 2. So, it would just give us a result of 3. X equal to y, it would just replace the value of x with y. So, y is having the value of 2 and x is having the value of 1. When this expression is evaluated, then x would be having the value of 2 itself. Okay. So, then we have selection statements. Selection statements is whether dependent upon a certain execution cycle, what would happen is that you have 2 branches. There is a value that is to be checked, and if the value of a is for example, in this case we have a value of a, and if the value of a is less than 5, then we go over this branch. If the value of greater than 5 or equal to 5, then we go over this branch. So, this branching concept or this selection concept is usually dealt with or mostly dealt with different number of directives in the languages and the programming languages, and in C++, one of these is addressed through if statement, if else statement and switches. If we are making one-way decisions, if we are just checking whether the value is less than 5, one decision, then we will use if. However, if we are checking whether the value of a is less than 5 or value of a is greater than 5, then we are using if else directive, and the multiple decisions are the combination of these if and else's. Supposedly we have this expression or this program. So, how would it be executed? We would give just the value of x equal to 10, and then we would check if the value of x is greater than 5. Because the value of x is greater than 5, we are using the directive if. If the value of x is greater than 5, then we would print this statement, otherwise nothing would happen. However, in the case of if else, which is the example of which is coming on the next slide, if there is something else that needs to be printed, then those expressions would be written over there like this. Okay, so if we are to make the flow chart of the two-way decision, then how would that particular flow chart look like? It would have a decision box, and then it would have 2 statements. Here the answer of true would be evaluated, and here the answer of false would be evaluated, keeping in mind that the test expression would always give us, like we have discussed before in the slides, that it would always give us either a 0 or a 1, or in other cases true or false. Okay. So, multiple decisions. For example, we have to check a person achieved marks 80 and we have to give the grade to that particular person. Now we have to check whether that person had a marks greater than 50, whether that person had a marks greater than 60, whether that person had a marks greater than 70. So we would do this in, what would happen, we would do this in the form of steps. We would use multiple steps. So in the first decision, we would check whether the person had marks greater than 50. If they had marks greater than 50, then a certain statement would be checked if they had marks greater than 60. Similarly, if they had marks greater than 70, and if they had marks greater than 80. If the answer is false, then that person is fail. If the answer is false for this statement, then that person has a B grade. If the answer is false for this statement, then that person has a C grade. If the answer is false for this statement, then the person has B grade. And finally, if the answer of this statement is false, then if the answer of this statement, this edge is true, then that person has an A grade. So we are making a multi-way decision. We are deciding a number of factors in a nested way, and then that nesting is done through using multiple if-else statements. Then we have a programming example of this particular idea. So we have x equal to 3 and we are checking, we are applying a number of checks on this. If x is greater than 5, then what would say x is greater than 5? Because x is not greater than 5, it would come to the next statement. It would check if the x is less than 5. If the x is less than 5, then it would print x is not greater than 5. However, there is another statement which needs to be checked, because these x greater than 5 is only checking if we are placing a number line and 5 is here, it is only checking these values, and x is less than 5, it is checking only these values. What about this value? We are also concerned with this value. So this value would be checked by this expression, else if x is equal to 5. So if x is equal to 5, then we would just print that statement that x is equal to 5. Here is another more simpler example. However, this is a nested if statement. Nested if means that we have one if and then we have another if. We are checking the value of x equal to 7. If the value is greater than 0, then we would check whether the value is less than 10. If the value is less than 10, then we would say that the value is between 0 and 10. And the answer of this expression, both of these expressions would be true. Why it would be true? Because x is greater than 0 and x is less than 10. So x is 7 and 7 is between both of these numbers. Okay. So the next statement or the next conditional statement that we have is a switch statement. This switch statement, the only difference between the switch statement and the if-else statement is that switch statements only check for equality of values. It only checks whether the value is equal to something. You cannot check greater than, you cannot check less than or less than or equal to, you can only check if the value is equal to something. And the syntax of switches is also a little bit more different. Here it says that the switch statement is usually more efficient. However, we have to clarify that particular statement. It is usually more efficient if we are only checking for equality. We are checking the value of certain something, then it is more efficient. However, in all of the other cases, if-else statements are more efficient. The switch statement can always be replaced by a series of else-if statements. That is true, because whatever we can do with switch statements, we can also do with if-else statements. Okay. So here we have an example of a switch statement. We have declared the value of day equal to 2. For example, we have Monday and Tuesday. So we are dealing with Tuesday and we have given it a number of a numeric value of 2. Monday is 1, Tuesday 2, and so on. So Sunday would be 7. So we are dealing with Tuesday and we are checking whether the value of what the day is. So if the day is 1, then we would say that it is Monday. If the value is 2, then we would say Tuesday. So how the syntax of switches works, that we use the word keyword switch and then we pass the variable and then we use case and then here printing and then case, another case. Usually what happens is that in most of the programming languages and even in C++, whenever we are dealing with switches, we also give a default statement. Default statement means that if the value is none, not the first case, not the second case, but the default case. If the default case occurs, then in this particular example we are saying that just print the statement other day. Okay. So repetition. The other thing that you have to understand related to conditional statements is repetition. For example, you had this statement, you wanted to print your name. However, whenever you write this statement, you can only do it, the console is only going to output your name once. What if you wanted to repeat your name 10 times? Then you have to use a directive which are called repetition directives in C++ language. Repetition. And for these repetition, we have three basic types of repetition. For loops, and these are also called loops. Repetition is done through a mechanism called loops, and we have three basic types of loops: for loop, while loop, do while loop. What is the basic difference between them? If we know the lower bound and the upper bound, we know that the value that we are going to print has to be printed at least 10 times, and we are going to print from 0 to 1. Then we know the lower bound and we know the upper bound. We know both of the bounds. So if we know both of the bounds, then we are going to use for loop. We know the number of repetition. While loop only checks for the equality or less than. We do not know how many times the repetition has to occur. How many times? Repetition is not known. We do not know if the repetition has to occur 10 times or if the repetition has to occur 11 times. We do not know. Then we are going to use while loop. For the do while loop, we know that it has to be repeated at least one times. At least one times. If we know that the value or the expression has to be printed or repeated or executed at least one times, then we use do while loop. Okay. So we are going to use some simple examples or see something simple examples for the working of these loops. So similarly, so for while loop, we know the number of iterations. Iteration is just another keyword for repetition. The number of repetition is known. You know how many times the loop has to occur. So if we see the syntax, we use the keyword for, and then we have this particular syntax, int I, or the variable which has to be repeated or which is iterating over it. We are starting it from 0. We are going till 5, less than 5. So it means 0, 1, 2, 3, and 4. And if you count them, this is 1, this is 2, this is 3, this is 4, and this is 5. So this loop is going to repeat 5 times, and this is just the post increment. What does post increment means? That the first time the value is printed and then changed. So that is what is going to happen. So if we output the value of I, first it is going to be 0, then it is going to be 1, then it is going to be 2, 3, 4. And we are not going to print 5. Why we are not going to print 5? Because of this statement, this particular statement, I is less than 5. If I is less than 5, then 5 is not going to be printed. However, if we want to change this, then how would we change it? We would write just this. We would add an equality to it. If we add an equality to it, then the loop would repeat how many times? 6 times, because it would go from 0, 1, 2, 3, 4, and 5. And 5 would be printed also. Here is another example of for loop. We are going from 0 to 10, and 10 is not being printed, and it is also using post increment. And then we are just checking, we are combining both things, both directives. We are combining for and if. We are using if in the body of for. So the loop would loop over nearly 10 times, but if the value becomes 5, then the loop would break. Meaning it would only run for 0, 1, 2, 3, and 4. It would not run for 5, because this particular statement would break the loop, would break the execution cycle, and the console would stop compiling your program. So next directive that we have is while directive. We do not know the number of iterations. Repetitions is not known. We do not know whether it is 10 or 20 or 100. We do not know how many times the statement is to be executed. So here in this example, we have declared the I to be 0, and we are checking whether whenever I is less than 5, we are just going to print its value. So we are going to repeat it, keep on repeating it until the value becomes 5. So here we are using post increment. It would go from 0, then 1, then 2, then 3, then 4. After 4th repetition, the value would become 5, and it would come and check this condition. It would check this condition here. While would simply behave as an if statement. Here I would be checked like this, and then we would have 5 is less than 5, and this would result in a false, and because this would result in a false answer, this while loop statement, whole while loop statement would stop executing, and it would break out of this execution cycle. Okay. So the next loop that we have is the do while loop. In the do while loop, we just repeat each statement at least once. So we have declared a particular variable, and we are printing its value, and then then checking the condition. First we are printing the value. Here you have a different keyword do, and then simple body of loop. We are printing the value, we are incrementing the value, and then we are checking. In the case of similarly in the case of while loop, we also use the word while. However, this while came before the statement was printed. However, in the case of do while loop, this statement, the while statement, comes after the statement has already been printed. This is the reason. This syntax is the reason due to which we say due to which at least one repetition occurs. So the working of do while loop is dependent upon this particular syntax, that we are using the do word, and then we are printing certain statements, and then we are checking. If we use the check before the do, then it would become a do while loop, and this do would not be there, and that statement would not, if the condition is false, then that loop would not be executed. That is it for today's conditional statements, our topic of conditional statements from the computer programming course with the course code 6900. I hope that you were able to understand all of these concepts in detail. Thank you. Allah Hafiz.